Bucka. Ha. You know the deal.
When we're asked to solve an algebraic equation, the question that we're being asked is, what is the value of the variable? Now, I realize most students would look at this question and they could very quickly realize that x is 2, because the only answer here that makes sense for x is 2, because 2 plus 3 is 5. So our answer is x equals 2. Well, the problem is we get into some equations that are a little bit more complicated than this. So we have to come up with a way to try to solve these mathematically. What I just did there is called solve by observation. We look at the equation and we think to ourselves, well, what answer makes the most sense for x? And in this case, what makes the most sense is 2. That's really the only answer it could be. But again, you're going to get into equations that are a little bit more involved than this, and where you're not necessarily going to be able to solve them by observation. So we have to come up with a way to solve this. And our final answer always looks something like this, where we have the variable by itself on one side of the equal sign. And it really doesn't matter what side of the equal sign. It could be on the left side or the right side. So if we go back to our original question here, we have x plus 3 equals 5. Now, as I talked about in the last video, we think of an equal sign like a balance scale. So what we're saying is x plus 3 is the same as 5. What I want to do here is I want to do what's called isolate the variable. The word isolate means get the variable by itself, which is how our answer always looks. The variable is by itself. So we have to ask ourselves, well, what do we have to get rid of here? We want the variable by itself on one side of the equal sign. So what we have to get rid of here is plus 3. As we saw in the last video, to get rid of plus 3, we do the opposite operation. So the opposite of adding 3 would be subtracting 3. So we take the left side of the equation and we subtract 3 from it. Now, as we also saw in the last video, an equal sign is like a balance scale. This is what I had on the left side of the equation on my previous line, just x plus 3. And again, we're saying x plus 3 is the same as 5. If I change one side of the equation, if I change one side of the balance scale, I have to change the other side in exactly the same way. So since I subtracted 3 from the left side, we also have to subtract 3 from the right side. And now we have a case where we can simplify. Well, plus 3 minus 3, as we saw in the last video, that essentially cancels itself out. It makes 0. X plus 0 is just x. And then 5 minus 3 is 2. So we've done what we needed to do. We isolated the variable, got the variable by itself. The variable is just x, and our answer is 2. And we could check to see if that's the right answer. If we substitute that back into the original equation, so our original equation was x plus 3 equals 5. If we take the answer that we got for x and substitute that back in, then the equation would look like this. 2 plus 3 equals 5. And if we simplify 2 plus 3, we have the statement 5 equals 5. So what we have here is a case where the left side does equal the right side. That's the nice thing about these algebraic equations, is you can always check your answer. So here's another example. Once again here you would be asked to solve this equation. This is one where I would say some students might not be able to solve by observation so quickly. Just like the last example, our goal here is to isolate the variable. Get x by itself. That's what our final answer is always going to look like. X is going to be by itself on one side of the equal sign. So what do we have to get rid of here to get x by itself? Well, in this case, we have to get rid of minus 2. As we saw in the introductory video, we get rid of operations by doing the opposite of what's there. So the opposite of minus 2 would be adding 2. Again, an equal sign is like a balance scale. I've changed the left-hand side by adding 2. So I have to do exactly the same thing to the right-hand side. We have to add 2 to negative 5. Well, now we've got a case where we can simplify. Minus 2 plus 2 makes nothing. X minus 0 is just x. And on the right-hand side, negative 5 plus 2 is negative 3. So we've done it. We've isolated the variable, got x by itself, and we found that the value of x is negative 3. again, we can check our answer. If we go back to the original equation, if we substitute our value of x, which was negative 3, into this equation, we have negative 3 minus 2. If we want to go ahead and change that to an addition question, that would be negative 3 plus negative 2. And negative 3 plus negative 2, of course, is negative 5. So once again, we've got a case where the left side equals the right side. If that's how it works out, you know you've got the right answer. Here's another example where, again, we would be asked to solve this algebraic equation. And we're saying 15 is the same as 3x. Our goal here is the same. Isolate the variable. Get x by itself. So once again here we have to ask ourselves, well, what's with x that's making it not be by itself? And most students would look at this and say, oh, well, I see a 3 with the x. We also have to think about what operation is with x. So we ask ourselves, what is 3 doing to x? When we have the number next to the letter like this, it means multiply. So what is 3 doing to x? It's multiplying. So what we have with x is times 3. So we have to get rid of times 3. As we saw in the introductory video, to get rid of multiplication, we do the opposite operation. So the opposite of times 3 would be divide by 3. Now, in this case, I've got the variable on the right-hand side. And it doesn't really matter where you isolate the variable. It can be on the left side or the right side. But again, an equal sign is like a balance scale. We're saying in the original equation, 15 is the same as 3x. So if I divide the right-hand side by 3, I have to divide the left-hand side by 3. And now we've got a case, once again, where we can simplify. Multiplying by 3 and dividing by 3 essentially cancels itself out. In this case, it makes 1. 1 times x is just x. And 15 divided by 3 is 5. So our solution, 5 equals x, is our solution. We've got the answer because we've isolated the variable. We got x by itself. And again, we can check our answer by substituting that value back into the original equation. So in our original equation, 15 equals 3x, we're suggesting that the solution for x is 5. So if we substitute that in, 3x means 3 times x. So since x is 5, we're going to multiply 3 times 5. And 3 times 5, of course, is 15. So once again, when we substitute in our solution, the left side is the same as the right side. So we can assume that we have the right answer. So here's another example where, once again, we're being asked to solve this equation. So what we have here is x over 3 equals 4, and our goal is the same, get x by itself. So we have to ask ourselves, well, what is with x that's not making it by itself? And in this case, it's over 3. And we have to think about, well, what operation is that? Well, over 3 means divided by 3. So what we want to get rid of here with x is divided by 3. How do we get rid of divided by 3? Well, we do the opposite operation. So we multiply by 3. Once again, an equal sign is like a balance scale. So if I change the left side at all, I have to change the right side in exactly the same way. We multiplied the left side by 3, so we have to multiply the right side by 3. Now on the left side, multiplying by 3 and dividing by 3, once again, cancel themselves out. They make 1. 1 times x is just x. And on the right-hand side, we have 4 times 3, which is 12. You can check your answer. If we go back to the original equation, x over 3 equals 4. We substitute our solution, which was 12. So instead of writing x, we write 12. And 12 divided by 3 is 4. So we have a statement that says 4 is the same as 4, which of course is true. So this solution must be true. Now that we've looked at a few examples of how to isolate the variable, I want you to go ahead and try a couple yourself. So what I'd ask you to do now is pause the video and go ahead and try to solve each one of these equations. Okay, so let's go ahead and take a look at the first one. So with the first one, we have to ask ourselves, well, what do we have to get rid of? We have to get rid of plus 3. And how do we get rid of plus 3? We subtract 3. If we subtract 3 from the left-hand side, we also have to subtract 3 from the right-hand side. Now here I've thrown in a little bit of integers, but if we go ahead and simplify the left-hand side, plus 3 minus 3 cancels itself out. It makes 0. X plus 0 is just x. And negative 1 minus 3 is negative 4. Hopefully you got a chance to actually check your answer. If you substitute that solution back into the original equation, -4 plus 3 is -1, so the left side equals the right side. For the next one, we have x minus 3 equals 2. Well, again, what do we have to get rid of to get x by itself here? We have to get rid of minus 3. And how do we get rid of minus 3? We add 3. If we add 3 to the left-hand side, we have to also add 3 to the right-hand side. When we go ahead and simplify here, x minus 3 plus 3 just makes x. 2 plus 3 is 5. For the next one, we have -5x equals 20. Again, our goal is to isolate the variable. So what do you have to get rid of? Here you have to get rid of times -5. To get rid of multiplication, we divide. Now, the thing here is you have to divide by exactly what's there. So if you have times -5, to get rid of times -5, you divide by -5. So that's also what we have to do to the right-hand side. We go ahead and simplify. Multiplying by -5 and dividing by -5 cancel themselves out. They make 1. 1 times x is just x. 20 divided by -5 is -4. And for the last example, again, we have to isolate the variable. So what do we have to get rid of? We have to get rid of divided by 4. And how do we get rid of divided by 4? We multiply by 4. If we multiply the left side by 4, we have to multiply the right side by 4. Multiplying by 4 and dividing by 4 essentially cancel themselves out. We're just left with x, and 7 times 4 is 28. If those were the solutions that you got to these 4 problems, congratulations, you now have a firm understanding of how to solve basic algebraic